Hello friends. Now this is the seventh conceptual idea from parabola. So the seventh conceptual idea is about the tangent and the normals. If you have the equation of the parabola like y square is equals to 4ax, for this parabola, at every point there exists a tangent. Okay, so we will find the tangents related to the points as well as tangents with the slope m. For y square is equals to 4ax, we have a general tangent equation with slope m is y is equals to mx plus a by m, and for y square is equals to 4ax, normal equation with slope m is given as y is equals to mx minus am cube minus 2am. And when coming for the x square is equals to 4ay, tangent equation with slope m is y is equals to mx minus am square, and the normal equation with slope m is y is equals to mx plus 2a plus a by m square. We need to memorize these four items to solve any problem in a simple and smart way. Right? So try to memorize these things, and among these, this one is the very useful and then repeatedly used item, that y is equals to mx plus a by m is the slope of the equation of the tangent with slope m. For suppose if this is the tangent, for this y square is equals to 4ax, so this y square is equals to 4ax equation is like this. For this equation, at a point P, you may say arbitrary point like 80 square comma 280. If at this point we have a tangent, and if the slope of this tangent is m, then its equation is y is equals to mx plus a by m, and the connection between the slope m and then this t is given as m is equals to 1 by t. We need to memorize that here, that m is equals to 1 by t. In the same pattern, at a point P 80 square comma 280, if you try to draw a normal, the normal is usually perpendicular to the tangent, you know it, and passing to that particular point. And if the slope of this normal is m, then the equation of the normal is given by this equation, and at this case, the relation between the slope and the t is given by m is equals to minus t. So usually there are equation of the tangent with slope m for y square is equals to 4ax, and an equation of the normal with slope m, and that tangent will touch the parabola at some point t, then related to that parameter t with the slope m is 1 by t, and here m is equals to minus t. In the same pattern, for x square is equals to 4ay, if you connect the parametric point t and then slope, here the slope and then t are connected by m is equals to minus t, and here the slope m and the t are connected by m is equals to 1 by t. Okay, as per our requirement, we will use equation of the tangent form in terms of m, or sometimes we will use equation of the tangent in terms of the t. Okay, so using these two, we are able to write the tangent equations for this type of waveforms also. For example, if I have the parabola equation like y minus k whole square is equals to 4a times of x minus h. If you try to write the equation of the tangent for this, you just observe this one. As we discussed in the third conceptual idea, this is there is nothing new, just we need to write x by h and y by k, and the equation of the tangent with slope m is given by y minus k is equals to m times of x minus h plus a by m. This is the equation of tangent for y square is equals to 4ax with slope m, and this is the equation of the tangent for y minus k whole square is equals to 4a times of x minus h with slope m. In the same way, we will write the normal with slope m, and again for x minus h whole square is equals to 4a times of y minus k. For this type of parabola also, we will write the equation of tangent and normal with slope m using these two equations, right? So among all these things, you need to memorize for y square is equals to 4ax, tangent with slope m and the normal with slope m, and the link between m and the parametric t and then m and the parametric t, right? So this is the seventh conceptual idea. When coming for the eighth conceptual idea, it depends upon S, S1, S11, S12. I think you are all aware about these notations like S, S1, S11, S12 from the circles onwards. Okay, so for example, if you have a parabola equation, then equation of the chord join any 2 points. If you say the first point as p x1 y1 and the second point q as x2 y2, then this equation of the chord is given by s1 plus s2 is equals to s1, right? And then this is one format, equation of the chord by knowing two endpoints of the chord. And another thing is, if you have a parabola and a chord whose midpoint is known as x1 y1, based on this midpoint, then this equation of the chord is given as s1 is equals to s11. And another thing is, if you have a parabola at a particular point p, if you draw a tangent, then equation of this tangent can be derived using s1 is equals to 0. Okay, and in some other cases, if you have two tangents for the parabola from an outside point, say for example I have a parabola where I can see, for example I have a parabola from an outside point. If I draw two tangents, then these two tangents are derived using this point p by s1 square is equals to s into s11. So totally there are here four different notations involved with s. One thing is s1 is equals to 0, s1 is equals to s11, s1 plus s2 is equals to s12, and s1 square is equals to s into s11. This is for tangent. Equation of tangent at a point p. This is for equation of the chord when midpoint of chord is known. And this is for chord when the endpoints of the chord as x1, y1 and x2, y2 are known. And this is for the pair of tangents when an external point P is known like this. Okay. See, these are the four different notations useful to find out the chord, equation of chords, equation of tangents also. And for example, if you have a general equation like the general second degree equation, any parabola can be converted like this: ax square plus 2hxy plus by square plus 2gx plus and then plus 2fy plus c is equals to 0. If this is the general parabolic equation, then to find the equation of tangent for this parabola at the point x1, y1, how can you find? See, you just differentiate it with respect to x. From there you just calculate dy by dx. After calculating dy by dx, you just calculate the value of dy by dx at this particular point. See, this is the dy by dx, and the value of dy by dx at this particular point will give a slope. See, this slope is nothing but whose slope it is? This is the slope of tangent. Then by using this point plus this slope, you can find the equation of tangent. And again, after knowing this m, from this you will get the slope of the normal as minus 1 by m. And here we have the point. Using these two, you can find the equation of normal also. For any type of parabola or for any type of curve, the general way of finding the equation of tangent is find the derivative and then find the derivative value at the point P as slope m, and then use these two to find the equation of the tangent. So this is also I am considering as the 8th conceptual idea, right? And one other thing what we need to know for sure to solve many problems is, for example, if I have a line and a parabola, I have a line and a parabola. Okay, how you will decide whether this line is a chord or tangent or neither a chord nor tangent for parabola? Neither tangent nor chord. See, I have a line and a parabola. So I need to decide whether this line is a chord or tangent or not tangent, not chord for the parabola. What I have to do? I need to make a quadratic equation using this line and the parabola. You just make a quadratic equation using this line and the parabola. After making this quadratic equation, you just find the roots or the delta value, discriminant, delta or roots. If you have two roots, then that is the chord for the parabola. If you have only one root, then that is the tangent for the parabola. If you have no roots, then that line is neither a chord nor a tangent for the parabola. So to decide whether a line is a tangent or chord for the parabola, you just make a quadratic using the line and the parabola. After knowing the roots, after finding the number of roots for the quadratic, you will decide whether the line is chord or tangent or neither chord nor tangent for the parabola. So this is the 8th conceptual idea. After this, I am going for the 9th idea. See, for the 9th conceptual idea, for example, if you have a parabola and you take any 2 points on the parabola like P and then somewhere Q, if this point P is at1 square comma 2at1 and this point Q is at2 square comma 2at2. At this point P, I have a tangent. At this point Q, I have a tangent. And then at this point P, I have a normal. And at this point Q, I have a normal. See, the point of intersections of the tangents as well as the normals for the parabola. The point of intersections of the tangent is directly given like a t1 t2 comma a of t1 plus t2. And another observation is here it is at1 square, here is at2 square. If you observe these two, this x coordinate is the what it is geometric mean of these two x values. And then this is a of t1 plus t2. Here for this point to at1, for this point to at2. This y coordinate is arithmetic mean of these two y values. Okay, if you know 2 points P and Q on the parabola, then the point of intersection of the tangents for these 2 points is given by this rule, as well as the point of intersections of the normals at this point is given by a of t1 square plus t2 square plus t1 t2 plus 2 is the x coordinate, whereas minus a of t1 plus t2 into t1 t2 is the y coordinate. So usually this point of intersection of tangents is useful in different situations and it is rarely used one, right? So if you have any 2 points on the parabola, we will have the point of intersection of tangents as well as the point of intersection of normals. And another thing is, if this PQ is the lattice rectum, then another useful thing, if this PQ is the lattice rectum, if PQ is lattice rectum, what will happen? If that PQ is lattice rectum, then this point of intersection of tangents will become like minus a comma 0 and the point of intersection of normals will become 3a comma 0. You need to identify. And what about that P? See, if PQ is the lattice rectum, then point P is a comma 2a. Point Q is a comma minus 2a. Then this point of intersection of tangent will become like minus a comma 0. This point of intersection of normal will become as 3a comma 0. And it is clear that this point of intersection of tangents as well as point of intersection of normals lies on the axis if the PQ is the lattice rectum. This is the 9th conceptual idea which explains us that point of intersection of tangents and point of intersection of normals, right? After this, I am moving for the 10th conceptual idea. See, for the 10th conceptual idea, what I am going to tell you is, if you have any 2 points on the parabola, for the 10th one, for example, if you have 2 points like a t1 square comma 2a t1 and q is a t2 square comma 2a t2. Okay, see, p a t1 square comma 2a t1 and then for space concern I erased it, and q is a t2 square comma 2a t2. See, based on this, if you just observe the t1 t2 values, if t1 t2 is equals to minus 1 and if t1 plus t2 is equals to 0 and the values of t1 t2 are plus or minus 1 and t2 is equals to minus t1 minus 2 by t1. I have 2 points on the parabola like p at1 square comma 2 at1 and q at2 square comma 2 at2, and then you just observe the values of t1 and t2. If those two values t1 and t2 are connected with these relations, then at this case we will say that PQ is the focal chord of the parabola, and at this case we will say that PQ is the double ordinate of the parabola. And at this case, if the values of t1 and t2 are plus or minus 1, P1 PQ is the lattice rectum of the parabola. And if you have a relation between t1 and t2 as like this, we will say that PQ is the normal chord. What is meant by normal chord? Normal chord of the parabola is nothing but normal at a point will pass through other one. See here, normal at P passes through Q. Normal at P passes through Q, so we call it as normal chord. See, if normal at a point will passes through the other point on the parabola, then the relation between those two is given by like T2 is equals to minus T1 minus 2 by T1. So I have 2 points on the parabola. related to these two parameters T1 and T2, with these relations I will confirm that the PQ is whether a focal chord or a double ordinate or lattice rectum or normal chord. And after that, if these are 2 points, then what is the distance between these 2 points? The length I am going to mention here. See, if the PQ is focal chord, then the length is calculated using the A times of T2 minus T1 whole square. And then if that is double ordinate, then the length is nothing but 4A times of T1. And if it is the lattice rectum, the length is directly 4A. And if it is the normal chord, then the length is given by 4A by T square of 1 plus T square power 3 by 2. See here, see T2 is minus T1 minus 2 by T1, no? Then the length of the normal chord in terms of T1, 4A by T1 square and 1 plus T1 square power 3 by 2. See, so there are 2 points on the parabola, different relations on T1 and T2. Based on the relations, the nature of the PQ and then the length of the PQ is mentioned. This is also one of the useful thing for JEE mains. Okay, these are the 10 conceptual ideas which are very helpful in attempting mains. Okay, so I will come with 10 conceptual ideas for all the chapters of JEE mains in the coming videos. Okay, see, just follow these 10 conceptual ideas as a revision of the parabola and share it for the required person, share it for the needy persons. Okay, and then do like and subscribe. Thank you.